Welcome back to the deep dive. Today, our mission is very specific. We're doing a really precise review of the core architectural bits of Agentforce. This is all designed to lock in that technical understanding to really ensure you've mastered how the system works. This is not about broad strategy. It's about the nitty-gritty configuration details, the constraints, the things that define a correct implementation.
That is exactly right. We've basically boiled down the key points from a lot of review materials. We're focusing on the concepts that, really separate a deep understanding from just a surface level one.
Right.
When you're trying to get certified on these systems, that clarity on the specific how and the why of the architecture, it's just critical. We're going to cut through all the noise and focus only on the objective functional facts.
So think of this as a sort of high-precision knowledge boost. If you've hit any friction points or, missed some of those key facts in your prep, this is structured to really lock those details in. We're looking at specific constraints, the exact fields to use, and the mandated processes that control how Agentforce behaves.
To really get this platform, you have to understand not just what the parts do, but the strict rules they operate under. We're going to examine those foundational limits and the exact mechanisms that dictate how the large language model decides what to do, what action to take, and which data to look at.
Okay, so our review today is broken into 4 key sections, and these really represent the most complex areas of configuration. First, we'll dig into the fundamental constraints of the agent core. That means agent types, data limits, and the selection mechanics the LLM uses.
A really crucial starting point.
Then second, we'll move into the detailed process for building and refining custom actions. Third, we'll get into data management and session persistence, which is a big one. We'll contrast how Agentforce deals with structured versus unstructured data and how it, manages memory.
And finally,
we'll wrap up with the essentials of deployment mechanics and performance metrics.
All right, let's get straight into it. We'll start at the very foundation, the agent core and its selection process.
We'll start with that foundational choice, agent type and its security context. This really depends entirely on where you're deploying it and who's going to be using it. So let's take a really common scenario. Imagine CloudKicks is launching a new partner portal, and it's built on Experience Cloud.
Okay.
The requirements are a bit complex. The agent needs to handle knowledge queries, so it has to pull up documents, but it also has to do transactional tasks, like submitting a new lead record into Salesforce. And here's the kicker. The agent has to be accessible only to authenticated partner users inside that secure portal.
Right. So when you lay out those requirements like that, authenticated users, a defined security perimeter like an Experience Cloud portal, and that need to do both knowledge retrieval and transactions, the right agent type becomes very, very clear.
And that would be?
The agent required to meet that specific set of needs is the service agent.
That distinction feels important. So why the service agent? Why is that the specific architectural fit here? And why wouldn't, say, a sales agent or a commerce agent work?
Well, it's really about how the service agent is architecturally designed. It's engineered for these customer-facing service workflows and, crucially, for working inside secure, authenticated places like portals. Since the user must be authenticated, that's a key security rule, and the tasks involve both information lookup and a standard service process like lid creation, the service agent just has the native capabilities for that mix.
So it's that dual nature of the service agent knowledge plus transaction that fits the partner portal's needs.
Exactly. And if you think about the other options, you can see the mismatch pretty quickly. A sales agent is really optimized for B2B workflows. It's focused on opportunity management, complex account data, pipeline health.
So it's a different world.
A completely different world. It can retrieve knowledge, but its core is built around the sales cycle, not general partner support. And a commerce agent is, even more specific. It's all about the buying journey inventory checks, order status, returns.
Yeah, I see.
So for a system that needs secure, authenticated access for general service and lead submission, the service agent is just the most appropriate and secure engine. Getting the system right means you have to recognize that fit between the function you need and the agent's core design.
Okay, that sets the stage for deployment. Now, let's switch to a core architectural constraint that really governs every Agentforce implementation, how it handles data sources. This is a foundational fact about the system's design.
And it's a constraint that can sometimes surprise people because it really forces you to be rigorous with your data governance.
The definitive fact here is this. An Agentforce agent can only have one data library assigned to it.
Just one. And this single library rule isn't an accident. It's a design choice that really shapes your whole implementation strategy. The agent relies heavily on what's called retrieval augmented generation, or RA, to answer questions from your company's own knowledge. So the quality of that data it retrieves is everything.
And if you had multiple libraries?
If you let the agent pull from, say, 5 different libraries that might have conflicting or outdated information, you introduce a huge amount of ambiguity into the LLM's reasoning.
So limiting it to one data library is basically a control mechanism. It forces good data governance and maintains a single source of truth for the RAG system.
Precisely. It helps prevent what people call data hallucination that's caused by internal conflicts in the knowledge base. In practice, this means you can't just point the agent at 6 different knowledge bases and hope for the best. You have to do a consolidation or federation project before you assign the library, making sure that one library is perfectly curated, indexed, and covers everything the agent needs. This constraint really forces a conversation about knowledge management long before the agent is even deployed.
Right. So understanding that constraint, let's now look at the actual brain of the agent, the LLM's reasoning, and how it selects an action. When a user types in a request, how does Agentforce decide what to do? Does it look for information first, or does it try to execute an action?
It's a dynamic, multi-step process, and it prioritizes structured, goal-oriented actions over just, grabbing knowledge. It relies on the LLM's ability to figure out the user's intent, not just matching keywords. And the flow has a very clear hierarchy.
Okay, can you outline that two-step logic for us?
So step 1 is all about the goal. The LLM's first job is to look at the user request and try to select a pre-configured topic and action, assuming a suitable one exists. This is the path the system wants to take because structured actions lead to predictable, traceable outcomes like placing an order.
That's the best-case scenario. Map intent to a defined action. But what happens if the intent is fuzzy or if there's no action that fits?
And that brings us to step 2, which is the system's generative fallback. If the LLM finds no matches, meaning it can't confidently map the request to a topic or an action, the LLM then tries to answer the user's request directly. This is where it uses its general LLM abilities combined with the knowledge from that single assigned data library we just talked about.
That's a really important distinction for anyone building or debugging these agents. It makes it clear that structured actions are the priority. The system wants to follow a defined workflow if it can.
Absolutely. Prioritizing the action selection makes the agent efficient at completing tasks. The direct answering part is for flexibility, but if you're relying on step 2, you're depending on RNLLM generation, which can be less predictable than a defined action. This whole reasoning engine shows the system is mapping requests based on a deep read of the user's goal, not just on whether they used a specific keyword.
Now that we get the priority, let's dig into how the LLM makes that decision in step 1. Let's say Universal Containers is setting up a service agent. They define 3 specific fields for a topic: a name, a classification description, and a scope. Which 2 of those actually influence the LLM's decision to pick that topic?
This is a critical point for configuration efficiency. It's about where you should focus your effort. You have 3 fields, but the Agentforce reasoning engine only uses 2 of them to choose the topic name and the classification description.
Okay, walk us through the roles of those 2 specific fields. How do they help with intent classification?
Well, these 2 fields are the essential text context that gets fed to the LLM during that classification step. The topic name is a concise label, a quick identifier, but the classification description, that's the heavy lifter.
Right.
It's basically a structured prompt that the specialist writes. It details in clear language what user intent this topic is for, what its purpose is, the kinds of things a user might say. The richer and more accurate this description is, the better the intent classification works. It's foundational.
It sounds like there's a lot of pressure on the team to get those descriptions perfect, since they're essentially writing the agent's logic.
They absolutely are. It's the specialist's chance to teach the LLM what the topic is for. And, if we connect this to the bigger picture, bad descriptions lead to misclassification, which leads to the wrong action being picked, and too much reliance on that step 2 fallback.
So what about that 3rd field, scope? If it's configured, why does the reasoning engine ignore it during selection?
The scope field is a completely separate thing. Its job is architectural and administrative. It's used to define things like visibility, who can see or use this topic, or which channels it's available on. It controls the topic's availability and context, but it doesn't provide any semantic information about the user's intent. So it is explicitly not used by the LLM reasoning engine for the selection process itself. Knowing that helps specialists put their writing effort where it actually matters: the name and the classification description.
All right, moving into our second section, let's shift from the agent core's decision-making to the actual tools it uses. Custom actions. If a team is building a custom agent action, they need a lot of pieces, input parameters, output types, permissions. But what is the absolute most fundamental component required to make sure the action can even be functionally selected and used by the LLM?
If we're looking at the foundational elements, the single most critical piece, the thing that's like a navigational map for the LLM, is the instructions.
Let's define that role. Why are instructions the functional core and not, say, the input or output definitions?
The instructions are the textual guidelines. They're like the internal manual for the LLM. They define the action's purpose, what it needs to run, what has to happen first, and what the result should be. They guide the LLM on how to use the action, and crucially, when that action is the right tool for what the user is asking. This text is the primary input the LLM uses to fit the custom action into its plan. Without clear instructions, the LLM can't confidently decide to pick that action, no matter how perfectly the parameters are defined.
So you're basically programming the agent's tool use reasoning through this detailed text.
Exactly. You're doing prompt engineering for the agent's internal thought process. The other elements, like parameters or data structures, they're essential for the action to run, but the instructions are what define the action's cognitive boundaries. They're foundational to that step one selection decision we talked about earlier.
Okay, so since instructions are the core, what's the best practice for writing and refining them to get the best accuracy? I imagine just a few sentences won't cut it.
No, not at all. This is where we go from basic definition to making it truly robust. The recommended approach for building solid custom action instructions is to use in-context learning. And the key practice is to always provide examples of user messages that are expected to trigger the action.
Why are examples so powerful here?
The underlying LLM is trained on patterns. So by giving it diverse examples, different ways a user might phrase a request for that action, you're giving the model the contextual breadth it needs. This hugely improves intent recognition because you're training it on the natural variety of real-world speech.
You're building resilience against ambiguity.
Precisely. If your instruction is just, this action checks order status, the LLM might struggle if a user says, where is my package? Or has my shipment left? By providing those specific examples in the action setup, you are explicitly mapping those variable phrases to the action you want, which drastically reduces the chance of misclassification or having to fall back to a direct answer. It's about validating the instructions against real-world conversation.
So once we've configured the action, written the instructions, and added examples, we can't just deploy it and cross our fingers. An Agentforce specialist has to rigorously test it with multiple real-world phrases before it's activated. What's the specialized tool that's mandated for this validation?
The required definitive tool for this critical pre-activation step is the testing center.
If we connect the testing center to the bigger picture of quality control, what role does it play in the life of a custom action?
The testing center is indispensable. It gives the specialist a controlled sandbox to systematically simulate real user interactions and actually watch the LLM's reasoning process. It's not just a pass-fail. Crucially, it lets you test all kinds of phrasing and intent nuances against the instructions and examples you wrote. It confirms that the LLM's selection confidence is high and that the mapping is accurate across a range of inputs. It's the final readiness check before activation.
So it's about making sure that the intent model, the instructions and examples working together holds up under pressure.
Absolutely. It's quality control with quantifiable feedback. It can show you why the LLM chose a certain action, or if it failed to, it might give you insights into the confidence score. This systematic testing is mandatory to prevent deployment problems where the agent just doesn't understand common user requests.
Our third section deals with how the agent accesses, and just as importantly, how it remembers data. Let's start with a scenario on data retrieval that goes beyond a standard database lookup. Universal Containers needs its agent to find similar, resolved cases based on the unstructured text in old case descriptions. This needs semantic search.
Right, and that immediately tells you that you need to move away from traditional structured data access. Retrieving based on the meaning or concept, not an exact keyword match, that requires a fundamental architectural shift in how that data is modeled and indexed.
So what are the necessary architectural steps to enable that kind of meaning-based retrieval of case data in Agentforce?
The steps are mandatory and very precise for this kind of content. First, you have to create an unstructured data model object, or UDMO, based on the standard case object. Second, you must then create an index on that UDMO.
Okay, let's break that down. Why is a UDMO necessary, and what is the index actually doing to enable semantic search? This gets into some core generative AI concepts.
It's a core concept. Standard data model objects, DMOs, are for structured data. If you were searching a case by status or creation date structured fields, a DMO is fine. But unstructured text, like a long, free-form case description, is complex. You want the agent to find similar cases not because they both use the word bug, but because they both discuss the concept of intermittent login failure.
So the UDMO is the container specifically built for that complexity.
Correct. UDMOs are engineered to handle large amounts of unstructured text. When you create an index on that UDMO, you're kicking off a process called vectorization. And vectorization converts the text, the meaning of the case descriptions, into high-dimensional numerical representations, vectors.
So if a traditional search is like looking up a word in a dictionary, what does the vectorized index let you do?
The vectorized index allows for semantic search. Instead of searching by keyword, Agentforce searches in a vector space. It finds proximity between the vector of the user's query and the vectors of the indexed case descriptions. This means the agent can find a resolved case about sporadic access problems when a new query says intermittent login issues, because the meaning, the semantic context, is close in that vector space, even if the words don't match. That capability, the UDMO and the index, is the foundation for intelligent, meaning-based retrieval.
That clarifies the infrastructure for long-term data access. Now let's pivot to immediate short-term memory. Coral Cloud Resorts needs their agent to remember customer preferences, say dietary restrictions or activity choices gathered early in a conversation. They're finding the agent forgets these details halfway through. They need reliable persistence.
This is a classic problem in conversational design, managing session state. The LLM's built-in memory is just fundamentally unreliable for long interactions. LLMs have token limits. As a conversation gets longer, the earliest parts just fall out of the context window. If you need a specific piece of data to survive a long conversation, you cannot rely on basic conversational memory.
So if the agent is forgetting things, what's the mandatory architectural step to make sure that data reliably persists through the whole session?
The necessary step is to implement a context variable to capture and store those specific customer preferences.
How do context variables solve the problem that the LLM's own memory structure creates?
Context variables give you a mechanism for deterministic state management. They are designed as dedicated session-wide storage for crucial bits of information. Once a preference is captured and stored in that context variable, it stays available for the entire session, no matter how many other things happen. It ensures the agent can reliably recall and apply those preferences consistently, which you absolutely need for complex, personalized service.
This means if the requirement is for guaranteed reliability for key data points within a session, the answer is always the context variable.
That is the architectural answer to guaranteed session state. It takes away the reliance on the unpredictable nature of the LLM's conversation window and replaces it with structured, deterministic data retention.
We're now moving into our final section, focusing on how these complex configurations get moved between environments and how their business impact is actually measured. Let's start with deployment metadata. A developer is using the Salesforce CLI to deploy agent components, topics, instructions, actions from a sandbox to production. These all have to be packaged together.
Right. When you're migrating a complex asset like an Agentforce configuration, you need a single comprehensive container that bundles all the related intelligence components together. This makes sure the agent's entire operational blueprint moves without missing any critical dependencies. This requires knowing the specific metadata.
What is the key metadata component to include in the package.xml file to successfully deploy these core agent elements?
The current definitive metadata component required is the Genie Planner bundle.
That sounds very technical. Let's dig into what the Genie Planner bundle actually is and why that specific name is so important to know.
The Genie Planner bundle is the official, comprehensive metadata container for Agentforce. It packages everything we've talked about that defines the agent's intelligence. The topics, the instructions, the custom actions, all of it. And the name is important because it represents the platform's current evolution towards generative AI planning. It's really essential to know this exact term and distinguish it from older legacy names like Einstein Planner Bundle or Bot Bundle, which refer to older chatbot architectures.
So mastering the system means knowing the current, correct deployment mechanism. If you use any other bundle name, the core intelligence just won't be migrated.
Precisely. This ensures your configuration is portable and that the logic is consistent between your environments. The GA Planner bundle is the single source of truth for the agent's configuration in the deployment pipeline.
Our final point tonight addresses the essential task of measuring the ROI and proving the agent's value. Universal Containers needs insights into the usability and effectiveness of their agents to drive adoption among their service staff. They need hard data. What tool should the AI specialist recommend to meet this specific business objective?
If the goal is to get quantitative insights into performance, usage statistics, and critically adoption metrics, the clear recommendation is Agentforce Analytics.
Can you detail what this tool provides that directly addresses measuring usability and adoption, taking beyond just simple session counts?
Agentforce Analytics is specifically designed for this. It gives you the deep quantitative data you need for optimization and adoption measurement. It doesn't just tell you the agent was used, it tracks the quality of that usage. This includes key metrics like action success rates, how often an action was picked and completed successfully, resolution time differences, and even drop-off rates so you can see where users are giving up.
This provides the data you need to find the bottlenecks.
Absolutely. By tracking these metrics, the specialist gets the data needed to systematically improve usability. For instance, if one custom action has a low success rate, the analytics points you right to where the instructions or examples might need work. And on top of that, the adoption metrics provide the evidence you need to show tangible value to the organization, which justifies investment and drives staff confidence in the tool. Without this feedback loop, assessing the agent's usability is just subjective and anecdotal. So to synthesize the most critical architectural points we've covered, let's just quickly revisit the core decisions that define a successful Agentforce deployment. We established the need for the service agent for authenticated transactional environments like partner portals. It has that unique blend of knowledge retrieval and process execution.
And we clarified the critical difference in data architecture for complex retrieval. UDMOs and indexing are the mandatory foundation for semantic search over text data, like case descriptions. It relies on vectorization and meaning-based retrieval.
Exactly. And for reliable state management across long conversations to fight that LLM memory decay, you must implement context variables for guaranteed session persistence of critical data.
And on the development side, the testing center is the mandatory tool for that pre-activation validation. It ensures the LLM's reasoning engine accurately selects custom actions, which confirms your instructions and examples are working.
Right. Architectural mastery really comes down to internalizing these specific choices. Knowing that the agent is limited to one data library, understanding that two-step priority stack for LLM decision-making, and confirming the exact deployment mechanism, the Genie Planner bundle. These are all non-negotiable facts for success.
We've reviewed the precise mechanisms that dictate how the agent selects the right action and how it ensures data persists through a single session. So we'll leave you with one final thought to consider as you solidify this. Given that the topic name and the classification description are the only two fields the LLM uses for that initial topic selection, and remembering the constraint of only a single data library, how should an Agentforce specialist strategically balance the need for hyperspecificity in that classification description to ensure accuracy, with the need for some generality so the agent doesn't miss similar but slightly different requests? It's a delicate design balance, bridging complex business vocabulary without introducing crippling ambiguity into the LLM's classification process. That's the critical design challenge that's built right into the system's core. Welcome back to the Deep Dive. Today we're doing something a bit different, a really focused tactical review.
Right, we're zeroing in on some of the key concepts from the Agentforce certification material.
Exactly. The ones that people commonly get tripped up on. And our mission today is to solidify your understanding of that core Agentforce toolkit.
And it's not just about knowing the right answer, it's about understanding the why behind it.
That's the key. That turns memorization into, real knowledge you can apply.
And the source material we're looking at covers really the whole spectrum. It starts with the basics, how an agent remembers things, how it accesses facts.
And then it goes all the way through the more technical side of things.
All the way to deployment, testing, even how multiple agents can talk to each other.
So we're going to structure this logically. I'll be framing the real-world problems, the why should you care part of it.
And I'll jump in with the technical specifics, drawing those distinctions between features that might sound similar but do very different jobs.
Which is always where the tricky exam questions live.
Always. So let's start at the absolute foundation, an agent's memory.
Okay, let's jump right into a really common problem. Memory. We've got a scenario from Coral Cloud Resorts.
CCR, yeah.
Their agent is talking to a customer, and early on, it gathers all these key preferences.
Things like dietary needs, what activities they like.
Exactly.
Yeah.
But then the conversation drifts. They talk about the weather, maybe booking times, and then later when the agent should be making a personalized recommendation.
It's forgotten those key details.
All gone. The standard conversation memory just isn't holding on to it.
And that's a classic problem. Conversation memory, it's really just a temporary scratch pad for the language model.
A scratch pad? How so?
Well, it's unstructured. It's just the recent history of the chat. It's great for keeping the flow of a sentence going, but it's not built for long-term, reliable data storage.
So it can get overridden or just pushed out of the context window as the chat goes on?
Precisely. It's designed for short-term flow, not long-term persistence.
So if CCR needs to hang on to that dietary preference for the entire session, what's the specific required solution here? I mean, why not just make the memory window bigger?
That's a great question, and it's a common thought. But making the window bigger just gives the model more unstructured text to sift through.
It doesn't make the data reliable.
Exactly. The required solution here is to create a context variable.
Okay, a context variable. Let's unpack that. If conversation memory is the messy scratch pad, what's the context variable?
Think of it like a dedicated labeled field in a database for that specific session.
Oh, okay.
You explicitly define it. You might call it customer dietary preference. And when the customer says they're gluten-free, you don't just leave that in the chat history.
You populate that specific variable.
You populate the variable with the value gluten-free. And now that piece of data is structured. It's guaranteed to persist for the whole session.
And it's easy for the agent's logic to retrieve, no matter how much the conversation has drifted.
Exactly. So the keywords here aren't just memory, but persistence and reliable retrieval. You're turning a passing comment into a structured piece of data.
Which is absolutely essential for CCR to deliver on that promise of personalization.
It is. So for the exam, if you see a problem where data is being forgotten over time, the answer is almost certainly going to involve a structured context variable.
Okay, that makes sense. So from the agent's internal memory, let's shift to its external source of truth, grounding.
Right. This is all about preventing hallucinations, making sure the AI doesn't just make things up.
And the scenario we have is from universal containers. They have a strict requirement.
A very common one.
Their support agents must answer customer questions based only on the company's official product tutorials and guides.
This basically mandates what's called a Retrieval Augmented Generation Architecture, RAG.
Right.
The agent needs a secure, designated pathway to access that private corporate data. You can't just let it use its general training knowledge for this.
Because that would introduce errors.
Yeah.
Outdated information.
All kinds of unacceptable inaccuracies, especially when you're talking about product specs.
So the specialist needs to get these guides and tutorials into the system. What is the required action to do that? Why not just, link to a folder on a shared drive?
The required solution, and the only correct one in this context, is to publish those product tutorials and guides as knowledge articles.
Knowledge articles. That sounds straightforward, but let's dig in. What's the strategic advantage of using knowledge over just linking to a document?
It's all about three things: control, indexing, and trustworthiness.
Okay.
When you publish something as a knowledge article, it enters the Salesforce platform's managed content system. So right away, it's secured by Salesforce permissions.
So you have access control.
Exactly.
Yeah.
And crucially, it gets indexed in a way that's specifically optimized for the Agentforce reasoning engine.
So it's not just a file. It's data that's been prepped for the AI to consume.
That's the perfect way to put it. It creates a trust boundary. The agent is told, your facts must come from this pre-indexed, pre-vetted source.
So Universal Containers gets data integrity, security, and factual accuracy all in one.
Correct. It ensures the answers are compliant with whatever internal standards the company has. So for the exam, if you see a requirement for secure, trusted, proprietary data to prevent hallucinations,
The answer is knowledge articles.
that's the foundational mechanism.
Okay, let's shift gears a bit to service efficiency. We've got two different scenarios here, but they both point to the same solution.
Right, they're two sides of the same coin. Both are about reducing agent handle time.
So scenario 1 from question 20 is Universal Containers wanting personalized AI-generated email responses that are, and this is key, grounded in knowledge.
And the second scenario, from question 32, asks for the feature that gives you generative replies or draft emails in a live chat, also based on recommended knowledge articles.
So in both cases, you need fast, high-quality, and factual text generation.
And the required solution for both is Einstein service replies.
And for the email one, it's specifically Einstein service replies for email. What's the real-world impact of this on a service team? How much time does this actually save?
The impact can be pretty significant. It's designed to slash the time agents spend just, typing.
Right, the manual composition.
Even if an agent knows the answer to a common question, they still have to write it out, format it, make sure the tone is right. That takes time.
So service replies just automates that first draft.
It can automate, say, 80% of the final draft. The human agent then becomes an editor and a reviewer, focusing on adding that final touch of personalization or handling the really complex parts of the issue.
And the key here, again, is that this isn't just generic text. It's grounded.
It's grounded in those recommended knowledge articles we just discussed. That's the critical link.
So speed doesn't come at the cost of accuracy.
Not at all. The system looks at the customer question, finds the relevant knowledge articles, and uses that trusted information to generate the draft. It merges the speed of AI with the reliability of official documentation.
Okay, so the takeaway for the exam is, if the scenario is about both reducing agent handling time, A&D providing knowledge-grounded, personalized drafts,
Whether it's email or chat.
the tool you're looking for is Einstein Service Replies.
Exactly. It's a productivity tool, first and foremost.
All right, so we've got an agent that can remember things reliably and is grounded in facts. The next logical step for a company is, well, how do we make it smarter for our specific business?
And then how do we prove it's actually working? How do we measure the value?
So let's start with making it smarter. This is where we go from a general assistant to a true specialist.
And we have a great scenario for this from Universal Containers, question 19. They want to boost sales productivity with generative AI.
But they have a very valid concern. A standard off-the-shelf AI assistant doesn't know their business.
Right. It doesn't know their internal acronyms, their specific sales stages, the history with a particular client. It lacks all that crucial CRM context.
A public model can't look at an opportunity and suggest the next best step based on UC's private sales playbook. It just doesn't have that knowledge.
So the question is, how do you make the AI deeply, natively relevant to your own company's data and workflows?
And the required solution is?
The required solution is to fine-tune the Einstein AI model with CRM data.
Okay, fine-tuning. This is a big one. Let's spend a minute here, because it's easy to confuse this with the grounding, with the reggae that we just talked about.
A very common point of confusion.
So why is fine-tuning the answer here, and not just, say, pointing the ARIG system at all the CRM data?
That's the core strategic difference you have to understand. Reggie is dynamic. It's reactive.
It looks up facts in real time.
Exactly. At the time of the question, it grabs relevant snippets of data and puts them in the prompt to inform the general model for one specific answer.
Okay, so what is fine-tuning doing differently?
Fine-tuning is a much deeper level of customization. You're not just informing the model temporarily, you are fundamentally changing the model itself. You're retraining it on a massive amount of your own proprietary data. All the historical accounts, opportunities, sales notes in the CRM, you are literally adjusting the model's internal weights and parameters.
So instead of the model just looking up a fact about UC's sales process.
The fine-tuned model starts to think and reason like a UC sales expert. It internalizes the language, the processes, the patterns of success and failure from your data.
So it's not just retrieving information. It's developing an intuition based on that data.
That's a great way to put it. It builds a kind of domain-specific intelligence. It can understand nuanced internal policies or prioritize leads based on your company's unique scoring model, things a general model could never do.
But that sounds like a much bigger lift, a bigger investment.
Oh, absolutely. The cost and complexity are orders of magnitude higher than setting up RAG. You need huge amounts of clean, high-quality data.
And if your data is messy, you risk embedding those flaws right into the AI's core logic.
Precisely. But the payoff is a real competitive advantage. So for the exam, when the goal is to alter the AI's core behavior to make it useful for a specific business unit using proprietary data.
The answer is fine-tuning.
Correct.
All right, so you've made this big investment, you've fine-tuned your model, but it's worthless if nobody uses
Or
it.
if it's not actually helping them do their jobs better.
Which brings us to measurement. The next scenario, question 17, is all about that. UC needs clear insights into how their agents are being used to drive adoption. You have to prove the value.
Absolutely. You need to show ROI, and you need to find the friction points. If agents are consistently failing on certain topics, people will just stop using them.
So there has to be a specific tool for this. What's the designated way to monitor success and measure the value of your Agentforce deployment?
The required solution is Agentforce Analytics.
Okay, Agentforce Analytics. How is this different from just building a standard Salesforce report or a dashboard? What makes it special?
It's purpose-built for governing AI performance. It focuses on business outcomes, not just, technical logs.
And what kind of metrics does it track that help with usability and adoption?
It really focuses on two big areas. First, you have your operational efficiency metrics.
Like handle time reduction, resolution time.
Exactly, the standard stuff. But the second part is what's crucial for adoption: effectiveness and usage.
So this is tracking how many people are actually using it and where.
Right. It tracks adoption rates across different departments, but it also tracks failure metrics. And the most important one is probably the fallout rate.
The fallout rate, what's that?
That's the percentage of interactions that started with the AI agent but ended up needing a human to intervene and solve the problem.
Ah, I see. So it's a direct measure of the agent's effectiveness.
It's a direct measure of friction. If that rate is high, it tells you the agent is failing in certain areas, which is going to kill user trust and stall adoption.
So this data lets you pinpoint exactly where you need to improve the agent.
Exactly. It moves beyond just, is the agent running, to, is the agent delivering value? It's essential for assessing that value and targeting your improvements to drive adoption.
Okay, we are now officially moving into the deep end, the technical side of things.
And this is where that precision in recalling specific names of tools and components becomes really important.
These are the kinds of questions that are easy to miss on an exam if you're not careful. Let's start with deployment.
We have a developer. They're using the Salesforce CLI, the command line interface.
And their job is to deploy the agent's core logic, the topics, the instructions, the custom actions, from a sandbox environment to production, standard DevOps stuff.
Right, so they need to specify the correct metadata component in their package.xml file.
What is that definitive component name for the agent's decision-making logic?
The required metadata component is the Genie Planner bundle.
A bundle. Okay, why is it bundle? Why not just deploy topics and actions as separate things like we do with Apex classes?
That's the key insight. The bundle is designed as a single cohesive unit to maintain what's called dependency integrity.
Meaning everything has to move together.
Exactly. An agent's logic is a chain. The topic, which is the user's intent, has to link perfectly to the action, which is the code that runs, and that link is governed by the action instructions.
So if you deployed them separately, you could end up with a topic pointing to an old instruction, and the whole thing would break.
Precisely. The bundle enforces that you move the entire planning structure at once, guaranteeing the agent behaves the same way in production as it did in the sandbox.
So just to be clear, the bundle contains the topics, the custom actions, and the action instructions.
All of it. It's the whole package. And for the exam, it's really important to remember that specific name, Gene Planner Bundle. Avoid similar sounding but incorrect terms like Einstein Planner Bundle or the older Bot Bundle.
Okay, so deployment's done, but that's useless without solid testing.
Right, and we need to look at two different phases of testing: what you do before you activate and what you do when troubleshooting later.
Let's start with pre-activation. A specialist has built a new custom agent action.
And before it goes live, they need to be confident that the agent will actually select that action correctly.
And not just for one simple test case, but across a whole range of different ways a user might phrase their request.
Multiple real-world user utterances, exactly. What tool do they use for that kind of bulk evaluation?
The dedicated environment for this is the testing center.
Okay, the testing center. What does it do that just, having a quick chat in a preview window doesn't?
The testing center is built for model evaluation at scale, not just a one-off preview.
I see.
You can upload a whole list of test cases, different phrasings, edge cases, common misspellings, and run them all at once against the agent's reasoning engine.
So you're stress testing the intent mapping.
Precisely.
Yeah.
The goal is to make sure the agent correctly maps all those different user inputs to the right custom action before it ever touches a real customer. Okay, so that's pre-activation. Now let's talk troubleshooting. The agent is live, and there's a problem.
And it's a specific kind of problem. The agent correctly identifies the user's general intent, the topic.
So the natural language understanding is working. It gets what the user wants.
Right. But the custom action that's supposed to run for that topic either isn't running at all or it's not performing as expected.
The what is right, but the do is wrong.
That's a great way to put it. And that immediately tells us where to look. The problem isn't the general intent recognition. It's in the specific rules that govern when and how that action is allowed to execute.
So if the topic selection is correct, What specific setting does the specialist need to go in and iterate on?
They need to refine the action instructions.
Okay, let's nail down that distinction one more time. The topic is the what, the user's goal. What is the action instruction?
The action instruction is the when and how. It's the gatekeeper. It's a set of very specific, granular rules for the reasoning engine.
Give me an example.
Sure. Let's say the topic is reset password. The action instruction might say, only invoke the reset password action if you have already confirmed the account ID and a verification code.
So it's a set of preconditions.
Exactly. So if the agent correctly selects the reset password topic, but it hasn't gathered the verification code yet, the action instruction will prevent the action from running.
And the fix is to adjust that instruction. Maybe it's too strict, or it's looking for a variable with the wrong name.
Precisely. You iterate on the action instructions to fine-tune the execution logic.
All right, this brings us to our final technical concept, and it's a big one. It's about how agents can work together at an enterprise scale.
Right. We're talking about multi-agent interoperability. As deployments get more complex, you don't just have one agent. You have many specialized agents and services.
And they need a way to talk to each other and leverage each other's skills dynamically.
The protocol that enables this advanced coordination is the Model Context Protocol, or MCP.
Okay, MCP. So the source material gives a specific example that best illustrates its use. What is that scenario?
The scenario is a legal assistant agent using MCP to dynamically find a document classification API to analyze case files.
Okay. Dynamically find. That seems like the key phrase there.
It is the absolute key. This scenario is the perfect illustration of what makes MCP special. It's about runtime service discovery.
Let's use an analogy here. If a traditional API integration is like having a static address book.
With a pre-programmed phone number for every service you might need to call.
What's MCP?
MCP is like a dynamic corporate yellow pages or a service broker.
Okay, explain that.
In the old static way, that legal agent would need to be hard-coded with the exact address of the document classification API. If that API's location changes, the agent breaks.
You'd have to redeploy the agent.
Right. With MCP, the agent doesn't need to know the address. It just needs to be able to declare its need. It says, I need a service that can classify legal documents.
And MCP goes and finds one.
The protocol layer goes and finds the best available service currently registered that meets that requirement, and it connects the two on the fly.
So the key isn't just that it can talk to another service, it's that it can discover that service at runtime.
That is the breakthrough. It means the enterprise can update, replace, or add new backend services without ever having to touch the front-end agent.
That creates a much more flexible and resilient system.
It's what allows these deployments to scale. The agents are no longer tightly coupled to specific integrations. So for the exam, when you see MCP, you should immediately think dynamic discovery and runtime invocation.
And that wraps up our detailed breakdown. We've gone from the simplest form of memory all the way to these complex, dynamic protocols. All right, to make sure this all sticks for the exam, let's do a final rapid-fire recap of the core facts.
Good idea.
If you need data to persist across a whole session, like a customer preference.
The answer is context variables.
If you need to ground your agent in official company documents to ensure accuracy.
You have to use knowledge articles.
What's the productivity feature for generating knowledge-grounded drafts for email and chat to reduce handle time?
That's Einstein service replies.
And the complex process of retraining the model's core logic on your own CRM data for a specific business unit.
That is fine-tuning the Einstein AI model with CRM data.
Okay, moving to the developer side. The single metadata component you use to deploy an agent's topics, instructions, and actions via the CLI.
The Genie Planner bundle. Can't forget that one.
The tool for evaluating action selection against many user inputs before you activate.
That's the testing center.
And if the topic is right but the action fails to run, what do you iterate on?
You iterate on the action instructions. That's the invocation logic.
Finally, the protocol that enables an agent to dynamically discover and invoke other services at runtime.
The Model Context Protocol, or MCP.
Okay, so we established that fine-tuning the model on CRM data gives a company a real competitive edge.
It makes the AI incredibly smart about their specific business, yes.
But that business data customer needs, products, sales strategies, it's changing every single day.
Which leads us to a final thought for you to consider. If fine-tuning is this massive upfront investment, that model's value starts to decay the second the training data it used becomes outdated.
So the provocative question is this. What continuous ongoing effort does a company need to maintain to stop that expensive fine-tuned model from becoming stale and eventually irrelevant?
You need to think about the entire life cycle. What are the processes and the infrastructure you need for continuous learning and continuous knowledge application?
A successful deployment isn't a one-time project. It's a commitment to continuous maintenance.
That's it, exactly.
Thanks for diving deep with us. We'll see you in the next one.
Okay, let's unpack this. We're doing a really focused deep dive today.
We are.
If you're preparing for the Agentforce certification exam, you probably know that the difference between passing and failing, well, it can come down to just a handful of very specific, highly technical details.
That's absolutely right. This isn't a general overview.
No, this is a focused review.
Oh.
It's tailored specifically for those areas that, we've seen consistently trip up candidates in practice tests. We're going surgical today.
That's the mission. We're going to bypass the general knowledge that you probably already have and dive deep into the things that matter for the exam.
Like what specifically?
The required metadata names, the precise functional mechanics of the key protocols, and the specialized testing tools you absolutely need to know.
The whole Agentforce lifecycle, basically.
Exactly. Success here means moving past just remembering things and really achieving a functional technical clarity.
Our source material for this is it's drawn directly from recent user feedback. We've identified 4 key pain points.
4 specific areas.
Right. First, the deployment lifecycle and the exact metadata structure you need to know. Second, the model context protocol, or MCP.
We'll be calling it MCP, yeah.
And then finally, we're going to get into the really practical stuff. The critical iterative process of action testing and refinement.
And the value here, I think, is that targeted preparation. You need that precise technical knowledge to be able to identify the correct answer when you're under pressure in the exam room.
Right.
So we're going to provide the deep context, the why behind the component names and their functions. We want to make sure you don't just know what the answer is, but maybe more importantly, why the other options are technically incorrect.
That makes sense. So to lay the groundwork, maybe let's quickly define that essential triad, the core of an Agentforce agent's intelligence.
Good idea.
We're talking about the topics, which, define the general intent or the area of expertise. Then the instructions, which are the natural language directives that guide the underlying planning engine.
The brain, really.
And finally, the actions, which are the actual technical tools or, the APIs the agent can actually use.
Topics, instructions, and actions.
That triad is the brain. And understanding how we move that brain from development to production, I think that's where we should start.
I agree. Let's jump right into Section 1, the Agentforce deployment lifecycle. And let's focus immediately on those critical metadata specifics.
Okay, so the scenario here is probably a familiar one for anyone who's done this. A developer has spent weeks, maybe months, in a sandbox environment perfecting that agent brain.
Right. They've tuned the topics, refined the instructions, built out the complex actions.
And now it's time to deploy this completed intelligence to the production environment. They're using the standard method, which is the Salesforce command line interface, the CLI.
And this is where the exam question always tends to focus. It's all about the packaging. When you're using the CLI, you have to create a deployment manifest.
The package.xml file.
Exactly, the package.xml. And that file tells the platform exactly which components to move. The platform it's very particular. It expects a singular component name that acts as the container for this entire intellectual bundle.
So you have this whole collection, the topics, the instructions, the actions, and it all has to travel as one complete recognized unit.
As one entity.
So what is that one component name, the one that encapsulates all of this for a CLI deployment?
The required component to include in your package.xml is the Genie Planner bundle.
Okay, Genie Planner bundle.
And that technical term, bundle, is really significant because it confirms that this entity is, in fact, a package. It contains multiple interdependent subcomponents.
So the Genie Planner bundle is basically the fully compiled blueprint of the agent's ability to reason and to execute things?
You could say that, yeah. It's not just code. It's the very definition of its intelligence.
And for the exam, you're saying understanding that full name is vital.
It's critical. Let's break down why that name is so specific and why the alternatives you might see on the exam are wrong. The Genie prefix specifically references the generative AI foundation of the Agentforce framework. This is crucial because it immediately differentiates it from older Salesforce systems. I see. Then the planner part signifies the agent's core capability. What does it do? It plans, it sequences, and it dynamically decides which action to execute next.
So the platform sees it not as just a collection of static tools, but as a generative planning entity.
Correct. The structure reflects the functionality. The Geno Planner bundle is the required packaging entity because it comprehensively encompasses that whole trio we talked about.
Topics, instructions, and actions.
All of it. If you use an incomplete name or a slightly different name, the deployment process is just going to fail. The platform won't recognize the full scope of what you're trying to move.
Which leads us directly to the common distractors, the wrong answers you'll see on the exam.
Right.
Why would an alternative, something like Einstein a Planner bundle, or maybe an older, simpler one like Bot bundle, be incorrect?
This is really a test of your understanding of the platform's maturity and its technical context. The Agentforce framework is the latest evolution of AI capabilities in the ecosystem.
Right.
So the metadata structure specifically reflects this shift to generative planning. Names like Bot bundle, that's almost certainly associated with legacy or, simpler conversational structures.
Like a rule-based chatbot.
Exactly. Things that lack the sophisticated reasoning and planning of a modern generative AI agent.
Okay, and what about Einstein a Planner bundle? I mean, that sounds much closer, but it's still incorrect.
It does sound closer, and that's why it's a good distractor. But it speaks to the platform's branding history. While Einstein AI is this huge suite of intelligence features, the current specific metadata component for the Agentforce planning capability uses the standardized GenAI prefix.
To denote its reliance on that core generative AI backbone.
Yes, and to distinguish it from some of the broader, often older Einstein services, what you are deploying is, technically, a generative AI planner. So for the exam, the key is memorizing that full specific name, GenAI Planner Bundle. It ensures you don't mistake it for an older or superseded structure.
Okay, so to synthesize this first section, for a developer deploying that intelligence triad, topics, instructions, actions using the CLI, the name has to be a Gene Planner bundle.
That's it.
Anything else is either a legacy system or an unrecognized component, and it's going to lead to a deployment failure because of an incorrect manifest.
That is a crystal clear takeaway. Now let's leverage that understanding. We've packaged the agent's intelligence. Now let's scale it up.
From one agent's internal components to how that agent interacts with the whole sprawling enterprise ecosystem.
Exactly.
This is where it gets really interesting for me. We're moving into section 2, talking about multi-agent interoperability and the architectural necessity of the Model Context Protocol, or MCP.
Right. And you have to think about a modern enterprise. No single agent can possibly hold every piece of specialized knowledge or access every single system. It's just not feasible.
So advanced AI deployments have to be decentralized.
They're inherently decentralized. And they rely on these robust interoperability protocols that allow specialized agents to not just communicate information, but to seamlessly discover and invoke specific external capabilities that they don't have natively.
So defining MCP's function is clearly key for the exam. What is its fundamental core role in this kind of decentralized environment?
Its defining role is to enable agents to interact with external capabilities. And specifically, the keywords here are runtime discovery and invocation.
Runtime discovery. Okay.
It provides the mechanism for an agent, maybe in the middle of a complex reasoning process, to locate and use a needed external service or an API dynamically. It's the language of dynamic capability request and resolution.
Okay, wait. Let me push back on that a little bit. If an agent just needs to talk to an external API, why can't it just be a simple predefined API call? I mean, we've had things like REST and SOAPy for ages for service invocation.
That is a crucial distinction, and the exam will test you on it.
Why does MCP need to exist? Why the focus on dynamic discovery?
Because traditional API calls are static. They're hard-coded. If your agent needs to call the GetInvoice service, the developer has to know the exact URL and the structure beforehand.
Right.
Now, imagine an enterprise at scale. Services are constantly being deployed, updated, maybe moved by completely different teams. If you hard-code all those connections, every single agent needs constant updating. It just introduces massive technical debt and brittleness.
So MCP is acting as a kind of abstraction layer, almost like a highly sophisticated service mesh, or maybe like a DNS lookup for capability.
That's a great analogy, a DNS for capabilities.
The agent isn't asking, call API X at this specific address. It's asking, I need the capability of X.
Exactly. And MCP provides that abstraction. It manages the runtime complexity of resolving that service request. The agent requests a capability, a functional outcome, and the Model Context Protocol does the heavy lifting.
What's the heavy lifting?
It's identifying available services, checking the context, ensuring compliance, and then providing the agent with the necessary invocation details, the specific API endpoint and parameters at that very moment.
Okay, let's anchor this. The sources gave a specific illustrative scenario. Can you detail that example that best shows MCP's unique use case?
Yes, the perfect illustration involves a legal assistant agent. So imagine this agent is tasked with analyzing a large new batch of case files from a client.
Okay.
The agent's core function is client interaction, but suddenly it needs to do a highly specialized task, document classification and sentiment analysis, but specific to legal terminology.
And that classification API, it might be running on a completely different cloud service managed by the firm's data science team, and it's only exposed through some internal capability broker.
That's exactly right. The legal assistant agent uses MCP to dynamically find that classification API. The agent doesn't have the API details hard-coded into its logic. Instead, it sends an MCP request that says, in essence, I need a document classification capability that can handle legal documents.
And the protocol layer handles it.
The protocol layer resolves the request, discovers the correct service endpoint that's running at that moment, and then it hands the details back to the agent to be invoked.
So the emphasis here for the exam has to be on dynamically find.
Yes.
If the data science team retires one version of that API and replaces it with a new one, the agent doesn't break. The MCP layer just discovers the new correct endpoint the next time a request is made.
That is the core takeaway. This dynamic discovery is what fundamentally differentiates MCP from simpler, static methods. It allows for this fluid, on-demand service integration.
And that's very different from, say, agent-to-agent or A2A conversational flows.
Completely different. A2A flows are generally about passing structured data back and forth. And static configurations, well, they mandate, the target endpoint beforehand. MCP is all about capability resolution in a decentralized system.
Which immediately brings up the question of scale. If we connect this to the bigger picture, why is MCP not just a nice-to-have, but really essential for building complex, scalable enterprise agents?
Just think about the operational overhead. If you have, say, 50 agents, and those 50 agents rely on 100 different external microservices, you're looking at managing 5,000 potential static connections. It's a maintenance nightmare.
I see.
MCP drastically reduces that cognitive load for developers and for administrators. By using a protocol for discovery, you get true enterprise agility. Teams can deploy their specialized capabilities independently, knowing that the MCP layer is going to handle the dynamic orchestration and integration across the whole agent ecosystem.
So it also ensures reliability. The agent's intelligence it's decoupled from the underlying service infrastructure.
Totally. The agent focuses on its planning and execution, and it just trusts MCP to provide the right tool at the right time.
It must promote reusability, too.
It absolutely does. Once a capability is exposed via MCP, any agent in the ecosystem can potentially discover it and leverage it. You're turning these siloed services into universal corporate capabilities.
So for the exam, it's the functional definition, runtime discovery, and invocation.
That's what you need to remember. But the architectural implication is this transition to a truly decoupled, resilient enterprise intelligence fabric.
That brings us really smoothly into Section 3. So we've defined how to package the agent's logic, the GNA Planner bundle.
Right.
And we know how to connect it to the outside world using MCP.
Yeah.
Now we have to pivot to the practical reality of making sure that logic actually works correctly before it ever sees a real customer.
And now we're moving into the tactical level of quality assurance. We're fine-tuning agent performance, specifically action configuration and validation. And this is often the most iterative, sometimes frustrating part of agent development.
Why is that?
Because you're dealing with the ambiguity of natural language and the non-deterministic nature of the generative AI planner. It's not always going to do the same thing twice.
Okay, let's start with subsection 3.1, pre-activation validation. The focus here is on a specialized tool, the testing center.
Right.
And the goal is very specific. An Agentforce specialist needs to verify that a custom agent action is being selected appropriately by the agent's intelligence layer, and they have to do this across various user inputs, the utterances, and crucially, before that action goes live.
The emphasis on pre-activation is paramount here. You want to catch those selection errors where the agent misunderstands the user's intent and chooses the wrong technical tool.
And an utterance, just to be clear, is simply the specific phrasing a user uses.
Yeah, the question, the command, the statement, whatever triggers the agent's reasoning process.
The challenge, of course, is that a single intent, like reset my password, could be phrased in a dozen different ways. I can't log in. Help, my access is locked. I need a new secret code.
Exactly. And the agent's planning engine has to map all of that ambiguity to one specific technical action. That mapping is where the errors creep in.
So what is the single recommended tool inside the Agentforce ecosystem for this specific verification task?
The recommended tool is the testing center. This is your specialized sandbox where you can, battle test the agent's interpretation skills.
The testing center is the right choice then, because it's explicitly designed for this kind of pre-release evaluation using test cases.
Right. It lets you simulate real-world usage without risking any production impact. You can input a whole range of representative user utterances, and the testing center gives you detailed visibility into the planner's decision-making process.
Let's get into the function of the testing center in more detail. What specific output does it provide that helps a specialist decide if the agent is actually ready for activation?
It gives you what's essentially a trace of the planner's reasoning. The critical insight it offers is the evaluation of the action selection process across all those different user utterances you test. So for each test case, the specialist can see, 1, the topic the agent identified,
Right.
2, the specific action the agent selected, 3, the confidence score it assigned to that selection, and 4, and this is crucial, it shows the confidence scores of the alternative topics and actions the agent considered but rejected.
That last point seems really important. It's not just enough that the agent chose the right action. You need to see why it chose it and make sure it didn't almost choose the wrong one.
You're validating the stability of the selection logic. Yes.
So you can see if it's confidently right or just barely right.
Exactly. And this raises another important point. We're focusing on action selection validation, not necessarily validating the action's execution.
Ah, okay.
The testing center primarily confirms the agent's cognitive mapping, that it understands the user's intent correctly. Things like unit testing or external API monitors, that's what you use to validate that the underlying technical action code works. Testing center validates the intelligence that links the user to the code.
So if I have, say, 50 test utterances all related to refund requests, I can run them all in the testing center. And if the agent consistently selects the process refund action with high confidence, then I know the intelligence layer is robust. But if it chooses check order status even once, I know I need to go back and refine the logic.
Precisely. The testing center validates this critical decision point based on a set of defined test cases. It confirms that the agent's logic is sound across diverse inputs before that logic ever impacts an actual user. It is the essential final checkpoint.
Okay, now let's use that output from the testing center to move into the next logical step. Subsection 3.2. Iterating on action selection logic. This feels like the diagnostic step after you've identified a failure.
This is a highly specific and very exam-relevant scenario. It tests your understanding of the agent's internal reasoning flow. The problem is defined like this. An Agentforce specialist observes that the agent is correctly identifying the general topic from the user's utterance, but it is repeatedly failing to select the appropriate action within that topic.
So the overall direction is correct. The agent knows we're talking about refunds, for example.
Right.
But it's choosing refund history when it should be choosing initiate refund. The failure is localized. So what specific configuration setting is the direct target for testing and iteration in this exact scenario?
Since the fault happens after the topic selection, the element that provides that more granular differentiating logic is what needs to be adjusted. The key iteration setting you must adjust, test, and refine are the action instructions.
Let's break down that sequential logic. I think this is critical for remembering it on the exam. Why the action instructions and not, say, the topic instructions or the topic utterances?
It's a two-step reasoning breakdown. Step 1. The agent gets the utterance. It uses the broader set of topic instructions and associated utterances to select the correct overall topic.
And the scenario says that part is working correctly.
Step 1 is successful. The agent knows the general domain. Now we move to step 2.
And step 2 is the planning layer's internal decision. Within this correct topic, which of the available tools, which of the actions, is the best fit for this specific user input?
And that is where the action instructions come into play. Once the topic is established, the agent consults the action instructions that are associated with each available action inside that topic. These instructions are the crucial localized guides.
So they direct the reasoning engine's decision-making post-topic selection.
Yes. They detail the specific conditions, the constraints, the priorities of that particular action. They give the planner the nuanced information it needs to make the final choice.
So if the agent chose the wrong action, it means the instruction for the correct action wasn't compelling enough for the planner.
Or, conversely, the instruction for the incorrect action was too broad and it improperly attracted the planner's attention. For example, if the agent is supposed to prioritize a check balance action, but it keeps selecting View Transaction History, the action instructions for check balance probably need to be strengthened. You might revise it to say something like, only use this action when the user explicitly mentions the current amount or available funds.
And that refining process improves the accuracy of that localized decision-making.
Exactly.
This also means that if we were to adjust the overall topic instructions, we'd risk disrupting step 1, the initial topic selection, which we already know is working.
You'd be using a sledgehammer when you need a scalpel. You have to focus only on the narrowest point of failure.
Okay.
So for the exam, always remember this flow. When topic selection is good, but action selection is bad, the fault is isolated to the action instructions. They guide that fine-grained differentiation between the tools within the topic. That's the only place to refine that specific logic.
The depth we've gone into across these 4 areas really solidifies the full life cycle, from packaging all the way to refinement. Let's do a final summary recap, tying these technical details back to the overall goal of passing the exam.
Sounds good. We covered 4 essential, highly technical components today, and they really map the whole journey of an Agentforce capability.
Okay, first, in the realm of deployment and packaging, we established the one required metadata component for moving the agent's core intelligence, the topics, instructions, and actions, from dev to prod via the CLI.
And that component is the GNet Planner bundle.
GNet Planner bundle. And we understand now that the name itself signifies a generative AI planning entity, which distinguishes it from any legacy bot structures.
Exactly. Second, for enterprise interoperability and the ability to scale, we detailed the fundamental protocol that enables dynamic service discovery.
The Model Context Protocol, or MCP.
Right. And its function is crucial for any agent that needs to dynamically find and invoke external specialized APIs at runtime. It provides that necessary abstraction layer over static connections.
Third, for pre-activation quality assurance, for mitigating operational risk. We identified the specific tool for testing the agent's cognitive mapping,
That's the testing center.
for evaluating action selection across all those diverse user utterances. It's essential for validating the stability of the planning logic.
And finally, regarding iterative refinement for precise execution, we focused on that surgical setting for correcting a faulty action selection, assuming the overall topic is already correctly identified.
Which is the action instruction.
The action instructions.
Yeah.
That's the localized logic that differentiates one tool from another within a given topic.
Mastering these 4 technical details, the metadata name, the protocol function, the testing tool, and the iteration setting, it seems absolutely vital because they test your knowledge across the entire development spectrum.
They do. The exam is designed to confirm that you understand the relationship between these elements. You deploy the intelligence with the bundle. You ensure it can find external tools using MCP, you validate its decisions in the testing center, and you refine its logic with the action instructions. It's a complete, structured understanding of the framework.
So what does this all mean for the future of enterprise tech, beyond just getting certified?
Well, the ability to modularize agent intelligence with the Genie Planner bundle, and then dynamically connect to services with MTP, that underscores a permanent shift in how applications are built.
We're moving away from monolithic, hard-coded applications.
We are. We're moving toward intelligent, loosely coupled orchestration hubs. And this shift towards dynamic intelligence, it demands a corresponding sophistication and quality assurance.
Right.
The technical knowledge you need for this exam, knowing to use the testing center for action selection and action instructions for refinement, it isn't just academic. It's a reflection of the rigor that's required for building reliable, trustworthy AI applications in a business environment.
If the agent makes a mistake in its planning, the business impact can be pretty significant.
It can be huge.
Yeah.
Which is why testing the cognitive layer is just as crucial as testing the underlying code.
So as a final provocative thought for you, the listener, to mull over, we discussed how MCP facilitates dynamic service discovery. But consider the implications if MCP gets extended to facilitate the dynamic discovery of specialized cognitive skills provided by other agents.
Interesting.
So if one agent is an expert in compliance checking and another is an expert in database querying, could the MCP protocol allow a general assistant agent to dynamically request and integrate their specialized planning capabilities? Could it form a decentralized intelligence fabric on the fly?
That concept dynamic capability discovery is not just the future of enterprise architecture, it's really the philosophical underpinning of highly scalable, resilient Agentforce deployments. The four components we reviewed today are the structural elements that make that future possible. Knowing them deeply is your key to exam success, and beyond that, to advanced application mastery. Welcome back to the deep dive. Today, we are not diving into a broad industry trend or a philosophical debate. We have a laser focus.
Very focused.
Our mission today is highly tactical. We are, acting as your specialized study session for the Salesforce Agentforce certification. We've compiled a list of the most common, most nuanced questions from practice scenarios, and we're going to unpack the architectural and technical why behind every single correct answer.
That's absolutely right. When you're preparing for a certification like this, it's not enough to just memorize definitions. The exam really tests your understanding of the platform's architectural limits and, its requirements.
Right.
We are focusing on the deep cuts, the interconnected concepts where prompt design meets data architecture. By spending time here on the edges of these technical requirements, you really solidify the core knowledge much faster.
So our entire deep dive is custom tailored around two critical, complex domains. First, we're going to spend a good amount of time on prompt engineering mechanics. We'll dive into the subtle differences between templates, the necessity of some specialized data formatting, and the hard constraints imposed by token limits.
And
then we'll transition to data cloud integration. We'll focus on how unstructured data must be modeled and indexed, the complexities of retrieving different file types, and the strict configuration rules that govern Agentforce data libraries.
Sounds good.
Okay, so let's unpack this. We need to start where the rubber meets the road.
Yeah.
How the AI agent actually receives and processes instructions. Prompt engineering. And the first point of confusion for a lot of exam takers seems to lie in choosing the correct tool for the job. Not all prompt templates are created equal.
No, they are not. This is a foundational concept we really need to nail down. The selection of the template isn't, it's not arbitrary. It reflects the intended output and the type of processing that's required.
So if the goal is text generation, you need a generation template.
Right. And if the goal is, say, structured synthesis, you need something else entirely.
Okay, let's start with a scenario that requires that synthesis, which we see referenced in question 5. Imagine a company, let's say Universal Containers, needs to generate a cohesive, detailed, and human-readable product description for a website or a marketing campaign.
Okay.
They need to pull from multiple structured fields, the product's SKU, its material, its dimensions, the pricing model.
Yeah.
All of that is stored in a structured product specification record.
Right.
Which template is the specific, correct mechanism to transform those raw structured fields into a flowing, marketing-ready narrative?
The required mechanism here is the record summary template. What makes this template unique and why it's the specific target of this question is its core function, which is synthesis.
Synthesis, meaning taking all those separate structured elements and weaving them together into a coherent paragraph.
Exactly.
Can you elaborate on why a standard field generation template wouldn't work here? What's the limitation?
Well, a standard field generation template is designed to populate a single field. Maybe it's calculating a price or generating a short tagline. It just lacks the infrastructure to manage the context and the flow you need for a multi-paragraph description.
So it's a one-to-one kind of operation.
Exactly. The record summary template, however, is purpose-built. It instructs the large language model to interpret all that input data, the SKU, dimensions, and so on, and translate that structured data into a descriptive, high-quality narrative output.
I see.
It is the architectural choice for turning structured data into flowing text that sounds like it was written by a human copywriter, and it ensures the resulting narrative is both consistent and accurate because it is grounded in the latest source of truth record fields.
So we're dealing with a transformation from structured data points to an unstructured narrative flow.
Okay.
Now, let's pivot to a related but subtly different requirement, which we see in question 35. Personalization at scale. So if UC wants to send an AI-driven, highly personalized marketing email to a customer using their expressed interest profile and recent product interactions, what's the prerequisite technical infrastructure for that?
Okay, so This moves us firmly into the domain of AI-driven content creation. The solution here is not just any email template. It must be a custom sales email template, which is grounded with specific Salesforce data.
Like those customer interest profiles and product information.
Exactly.
Why the emphasis on custom and grounded? Why can't we just use a standard sales email template and drop a few merge fields in there?
Well, standard templates are basically static placeholders. They don't provide the necessary scaffolding for the LLM to generate novel content dynamically.
They're just fill in the blanks.
Right. The custom sales email template provides the structure where the LLM can generate the text, but the grounding is the critical step. You're forcing the LLM to stay tethered to the facts specific to that individual customer. I mean, if the LLM generates a fantastic, persuasive email, but it talks about a product the customer already owns, the whole effort fails.
Of course.
Grounding ensures the content is relevant, accurate, and personalized based on the customer's latest interaction history. Without grounding that template, using those specific customer details, the interest profile, the account tier, recent purchases, the resulting AI-generated content is just generic. It lacks the personalization that drives conversions.
So the crucial distinction for the exam, then, is recognizing when you need AI to write versus when you need AI to synthesize.
That's it.
Writing requires the custom sales email template structure plus that dynamic grounding, whereas synthesizing structured data into a narrative uses the record summary template.
Precisely. It really just comes down to intent. Are you generating a static output from dynamic data, or are you generating a dynamic novel output based on grounded context?
Here's where it gets really interesting. We've established that grounding is essential. But what happens when the data we need to pass to the LLM for grounding is complex? Like a multi-layered object structure that needs to be represented as JSON. We're moving far beyond a simple contact name or a date field. This is question 16.
This is a classic technical friction point between a traditional relational database like Salesforce CRM and a large language model that's designed to consume text. The core challenge is that standard merge fields, when they pull complex data, often return raw, unstructured text strings.
And what's wrong with that?
Well, if that data is supposed to represent a JSON object, say a list of complex product configurations with nested details, a standard merge field might return it inconsistently. You might get unescaped quotes or just messy formatting.
And if the LLM receives messy, unstructured data that it's supposed to interpret as structured JSON, what's the risk there?
The risk is total parsing failure. Or worse, you get unpredictable output. LLMs are powerful, but they're also very sensitive to input formatting when they are expected to produce structured output. So to guarantee the LLM receives a reliably structured input, a perfectly clean, consistent JSON string, we can't rely on the default platform mechanics.
So the solution is to take control of the formatting ourselves. We have to preemptively clean and structure the data before it even hits the prompt builder workspace.
Exactly. The required technique is using Apex code to return a JSON-formatted merge field.
Ah, Apex.
That is the necessary technical bridge. Apex is leveraged here as a preprocessor. You write a short Apex class that fetches the complex CRM data, serializes it robustly into a perfect JSON string handling all the necessary escaping and formatting.
And then what?
And then it exposes that result as a custom field specifically designed to be consumed by Prompt Builder.
Wait, but isn't requiring Apex a huge lift for non-developers? Is there any simpler standard declarative mechanism that Prompt Builder should have but doesn't, that forces us into this custom solution?
That's a great question, and it really highlights the current architectural requirement. The declarative tools within Prompt Builder are excellent at connecting standard fields or related lists.
But not for this.
Right. When you need programmatic control over the output format, not just the data itself, you have to step into Apex. This requirement emphasizes that the Agentforce certification tests your knowledge of these specific technical workarounds that are needed to ensure data quality for the LLM consumer. You are basically building a customized, perfectly packaged payload for the AI agent.
That distinction is vital. Now let's shift focus slightly to data security and relevance, which is addressed in question 14. When we are dynamically grounding a prompt with up-to-the-minute Salesforce record data, what is the best practice method that ensures both high accuracy and strict security compliance?
The best practice method, and the answer the exam is absolutely looking for, is dynamic grounding with secure data retrieval.
Okay, let's break down both parts of that. Why dynamic?
Dynamic retrieval means the data is fetched at the moment the prompt is executed. You're not relying on data that was cached or, last indexed hours ago.
So it's always fresh.
Always. For example, if an agent is responding to a customer service inquiry about an open case, Dynamic grounding ensures the agent sees the status change that happened 60 seconds ago. It guarantees the context is current.
Okay, that makes sense. And what does the secure data retrieval component enforce, particularly regarding the listener-specific Salesforce security model?
This is the crucial security implication. Secure data retrieval enforces the running user's profile and permission sets. It ensures that the data pulled for grounding, even if it's technically available in the database, is only retrieved if the user who initiated the agent action has the proper security clearance to view that data.
So if a lower-tier support agent runs a prompt that attempts to ground itself with confidential executive notes, and that agent doesn't have the necessary permission set, what happens? Does the grounding fail, or is the data just redacted?
Exactly. The system respects field-level security and record access rules. If retrieval fails those checks, the data is not included in the prompt payload. It maintains data governance.
I see.
If you relied on a static, pre-indexed copy of the data, you would risk exposing information that the user isn't authorized to see. So dynamic, secure grounding is the non-negotiable best practice for maintaining both data integrity and security posture in Agentforce.
Every large language model operates with a finite capacity, its token limit. In Agentforce, this constraint becomes acutely problematic because of grounding, right? We're often shoving massive amounts of context into the prompt payload.
We are, and every bit of context you shove into that prompt payload, whether it's the specific instruction set, the conversation history, or the retrieved grounding data, it chews up your total token budget.
And this isn't some abstract limit.
No, not at all. It's a hard technical boundary. If the combined size of the instruction and the grounding data exceeds the model's capacity, the input is truncated. It just gets cut off.
And when the context is truncated, what is the observable effect on the agent's response?
Well, the agent doesn't send an error message saying, "Warning, I ran out of tokens." It just silently fails. If the truncation happens mid-sentence in the grounding document, the LLM only receives the first half of the critical information.
Which leads to?
It leads directly to incomplete, confusing, or worst of all, inaccurate and fabricated agent responses, hallucinations, because the model is trying to logically complete a thought based on insufficient context.
That sounds like a silent architectural failure waiting to happen. So if an Agentforce specialist is reviewing a prompt setup to prevent token limit overflow due to excessive grounding data, say, they have a massive custom object they're using for context, what is the single authoritative source they must check to diagnose and preemptively manage this risk?
They must review model limitations directly within Prompt Builder.
Why Prompt Builder specifically? Why isn't this information in the Data Cloud Index configuration or, somewhere in the trust layer setup?
Because Prompt Builder is the configuration layer where you select and configure the specific large language model being used. The model's capacity, its total token limit, is a metadata attribute that is tied directly to that selected model. It's like the LLM's spec sheet.
Got it.
Reviewing offset queries focuses on database efficiency, and the trust layer manages data security. Neither of those tells you the inherent capacity of the LLM engine itself. Prompt Builder is the necessary source of truth for understanding the maximum payload size the chosen AI engine can handle.
So if you're concerned that your custom Apex-generated JSON payload might be too heavy, Prompt Builder is where you check the weight limit of the truck before you load the cargo.
That's a great analogy.
This wraps up the prompt mechanics. We've covered template function, data preparation via Apex, and the final constraint check in Prompt Builder. Now, shifting focus entirely, we've built the perfect prompt, but that prompt is useless if the underlying data, especially the messy stuff, isn't indexed efficiently. Let's move to the foundation, how Data Cloud handles the information the agent needs to access.
This transition is crucial because it moves us from input instructions to knowledge architecture. Agentforce agents require semantic search capabilities to retrieve grounding context. And semantic search, finding a result based on meaning rather than keywords, demands a very specific data preparation structure within Data Cloud.
Let's look at question 1, a scenario involving leveraging past knowledge. Universal Containers wants their service agent functionality to answer customer questions by finding similar, successfully resolved cases from history.
Okay.
These cases contain complex, often long text descriptions, the troubleshooting logs, the customer's detailed problem report, which is the most valuable part.
Right. This is a classic example of needing to bridge the gap between structured records and unstructured knowledge. As you said, the case description and resolution notes are the meat of the knowledge. Standard data model objects, DMOs, are excellent for the case metadata.
That's structured stuff.
The structured stuff, case ID, status, owner, date closed. But DMOs are not optimized for housing and indexing massive, complex blocks of text for meaning-based retrieval.
So if we try to put that massive troubleshooting log into a standard DMO text field, what happens when the agent tries to search for similar cases?
You would be stuck relying on keyword search, which is very brittle. If a customer asks about a malfunction in the Series X power supply, and the resolution notes use the word faulty PSU, a keyword search might miss that connection entirely.
Because the words don't match exactly.
Right. We need the agent to understand that malfunction and faulty are semantically related, and that power supply and PSU refer to the same concept.
That requires vectorization, correct? Converting the text into mathematical representations of meaning.
Exactly. And to containerize that text for vectorization, the Agentforce specialist must create an unstructured data model object, UDMO, based on the case object. UDMOs are the designated containers for large, complex text or document data, specifically because they are designed to be indexed for semantic search. They signal to Data Cloud that this data needs the heavy lifting of vector embedding.
So the UDMO exists to hold the long text fields from the case object. But that alone doesn't enable the semantic search, does it? What is the critical final step that actually unlocks the agent's ability to perform this meaning-based retrieval?
The critical final step is to create an index on that UDMO. The index takes the UDMO's text content, converts it into those high-dimensional vectors, and then stores them in a format optimized for fast, meaning-based comparisons.
So without the index?
Without that index, the UDMO is just a static container of text. The index transforms it into an active, searchable knowledge base. The exam tests your understanding that both the UDMO, the container, and the index, the processor, are necessary components for enabling Agentforce to retrieve complex case knowledge accurately.
That distinction between the DMO for metadata and the UDMO and index for knowledge is crucial for the certification. It proves you understand the prerequisites for effective knowledge grounding.
Let's move on to leveraging Data Cloud's real strength, the unified customer profile, which often includes vast amounts of activity data.
Okay. The scenario for question 18 involves a unified contact and data cloud, logging all their digital activities, web clicks, app usage, downloads. The goal is to use this rich dynamic activity data inside a prompt template that's associated with the contact object to generate insights, like a deep interest analysis. The problem is that the activity data is typically massive and compiled from external sources.
Right. The core contact record in the CRM isn't where this data lives. Data Cloud has synthesized and compiled it into a massive related activity stream. We need to create a connection path that allows the prompt to access this stream dynamically, ensuring that when we run the prompt for Contact X, we get only Contact X's activity history.
This requires specific configuration steps. So what's the Data Cloud side configuration that makes this activity data accessible via the core contact record?
The first step is to add the activity records as an enrichment-related list to the contact within Data Cloud. This is Data Cloud essentially saying, here is all the aggregated, cleaned web activity data, and we are structurally linking it back to the unified contact record.
Okay. Once that structural link is established in Data Cloud, how do we operationalize it in Prompt Builder?
You then move to Prompt Builder. You pass the core contact object into the prompt template workspace as the primary context object. Then, most critically, you must utilize related list grounding in Prompt Builder. This mechanism allows the agent to dynamically query and pull that newly created enrichment-related list, fetching these specific, relevant activity records for the contact currently being processed.
So the related list grounding is the feature that leverages the architectural work you did back in Data Cloud.
Precisely. The outcome is elegant. The prompt can now dynamically pull the full, deep web activity history, which could be hundreds of activity records, and use that high-fidelity context for advanced analysis.
Like inferring the customer's level of interest in specific product categories based on pages they viewed, not just static fields.
Exactly. It is the architectural glue that allows Agentforce to leverage Data Cloud's 360-degree view for meaningful grounding.
We've established that indexing unstructured data is vital, but what about attachments? Question 22 highlights a common failure point. An agent is perfectly summarizing knowledge articles, but it's completely ignoring the critical technical details that are only contained within attached PDF files.
This is a matter of index scope, which the specialist must diagnose. When the Data Cloud search index was configured, it successfully processed the main text fields of the knowledge article DMO. However, it failed to index the content within the attached files.
Hmm.
The index treats the PDF attachment merely as a file pointer, not as text content to be vectorized. If the agent can't read it, it can't summarize it, even if the file is technically attached to the record.
So the fix requires going into the index configuration and explicitly instructing the system to dive into those files.
That's right. The Agentforce specialist must ensure the Data Cloud search index is configured to include the content of these attached files.
So you're basically expanding the scope.
That's the key technical correction. You need to configure the index to use a file parser, often called a crawler or document processor, that can extract the text from complex formats like PDFs and other documents, and then vectorize that extracted text for inclusion in the semantic search index. It's an administrative setting that expands the scope of the index from the parent records fields to include the related file content itself.
Now let's move from basic indexing scope to more complex retrieval requirements. This brings us to the necessity of custom retrievers, which are addressed in questions 23 and 24. We have unstructured warranty information indexed in Data Cloud. We need to answer user questions, but the results have to be precisely filtered by product line and ranked by recent updates.
This is where standard semantic retrieval hits its limit. A default retriever is brilliant at finding text blocks that are semantically most similar to the user's query. It scores content based on meaning.
But that's not enough here.
No. The requirement here is to apply structured, metadata-based logic. We need a hard filter on the product line field and an ordering based on the last modified date field. The standard retriever just ignores this metadata structure during its semantic scoring process.
So the simple semantic relevance score is no longer sufficient because we are introducing requirements that are fundamentally structured, like a database query. We need to combine the power of vector search with the precision of SQL-like filters. What is the specialized tool required to achieve this complex combination?
The specialist must configure a custom retriever in Einstein Studio. This is the key component that allows you to inject custom query logic into the retrieval pipeline.
Can you describe the mechanism of the custom retriever? Why does it need Einstein Studio, and what does it achieve that the default option doesn't?
Well, Einstein Studio is the development environment for these advanced AI capabilities. The custom retriever configured there acts as an intermediary layer. It first takes the user query and identifies the relevant filters like product line X. It then structures the retrieval process. It instructs Data Cloud to only retrieve semantically relevant text blocks that also meet the specific field filters defined in the metadata.
So it does two things at once.
Yes. For instance, it might tell the system, find all documents related to power supply malfunction, but only those where the associated metadata field product line equals series 9000. Crucially, once the results are filtered, the custom retriever then applies the final ordering logic, ranking the results based on last modified date, ensuring the agent pulls the most recent relevant warranty information.
So it harmonizes the unstructured semantic search with structured metadata filtering and ranking.
That's it, exactly.
So the custom retriever is essentially the bridge between the freeform knowledge contained in the UDMO index and the structured data context contained in the DMO metadata. It ensures the agent gets results that are precise in content and correct in context. Let's shift gears one last time in this section to architectural rules and constraints regarding knowledge governance, starting with question 28. What is the hard architectural limit regarding how many data libraries can be assigned to a single Agentforce agent?
The rule is a firm constraint that often appears on the exam. An Agentforce agent can have only one data library assigned to it.
Why such a restriction? Why can't we assign 3 libraries, one for policy, one for products, one for cases, to a single agent?
The rationale is domain consistency. If an agent had multiple libraries, you would risk conflicting grounding contexts. For example, internal policy and public-facing marketing copy might use different definitions for the same term. By enforcing the one-to-one relationship, you ensure that Agent A, who handles external customer support, is strictly grounded in the public knowledge library, while Agent B, who handles internal IT tickets, is strictly grounded in the internal manuals library. It prevents scope creep and ensures every agent has a specialized, reliable domain of knowledge.
That makes perfect sense for governance and predictability. Finally, question 31. What is the correct dual configuration required when setting up a data library specifically for knowledge articles, focusing on indexing public content and ensuring transparency?
This question tests both security and trust requirements. The correct configuration involves selecting 2 key settings, public knowledge article and show sources.
Let's address public knowledge article first. What is the implication of selecting that setting?
Selecting public knowledge article ensures security and compliance. It directs the indexing process to only process and expose knowledge content that is explicitly marked as public.
So internal drafts.
Any internal drafts, confidential policies, or articles in pending status are automatically excluded from the agent's knowledge base. This is the security boundary.
And show sources. What vital function does that serve for the end user?
Show sources is critical for transparency and user trust. When the agent generates a response grounded in the knowledge library, this setting ensures that the agent displays the grounded references, the titles, and links to the specific articles it used to formulate the answer.
So you can check its work.
Yes. This allows the end user to verify the source material, which is essential for building confidence in the AI-generated response, especially in regulated or sensitive service environments.
It's not enough for the answer to be correct. The user needs to know where the answer came from. Security via content restriction and trust via source citation.
Exactly.
So what does this all mean? We've drilled deep into the architectural choices that determine whether an Agentforce implementation is accurate, secure, and performant. Let's maybe synthesize the 3 biggest architectural takeaways that were the focus of these particularly tricky certification questions.
The complexity of Agentforce architecture often boils down to managing the data interfaces. First, you must internalize the difference between data model objects, or DMOs, and unstructured data model objects, UDMOs. This is a critical architectural decision. DMOs handle the structured metadata fields efficiently, but UDMOs are the non-negotiable container needed for large, complex text-like case descriptions or documents, and they exist solely to enable the power of semantic indexing and vector search. If you're dealing with the meaning of long text, you need a UDMO.
Okay, that's one. What's the second?
Second, the necessity of pre-processing complex data before it hits the LLM. If you need to transfer complex, structured data-like hierarchical records into a reliable format for the LLM, you cannot rely on default merge fields. This mandates the technical workaround of using Apex code to reliably format the input data into clean JSON and expose it to Prompt Builder.
Apex is the bridge. Yeah. And third?
And third, remember the architectural governance constraints we just reviewed, the one-to-one rule. A single Agentforce agent can only be assigned one data library. This ensures that the agent's specialized purpose and its grounding context remain consistent and reliable, preventing confusion or contradictory knowledge sources.
Mastering these points means moving beyond simple platform familiarity to understanding the underlying architectural mandates. You know why the standard tools fail, and why the specific specialized solution, whether it's a UDMO, an Apex class, or a custom retriever, is required to ensure the agent is functional, accurate, and secure. That is the core knowledge needed to pass this certification.
Absolutely. We spent considerable time on the most complex areas, involving customization specifically, using Apex to structure merge fields, and, even more critically, implementing custom retrievers in Einstein Studio to apply sophisticated field filters and recency ranking to unstructured data. These areas require not just platform knowledge, but a deep understanding of data retrieval logic.
This raises an important question. The custom retriever models we discussed, which allow us to apply metadata filters like product line and last modified date to an unstructured search, are currently configured to enhance relevance and filtering. But as Agentforce platforms continue to mature, how will these models become more tightly integrated with enterprise security and compliance policies?
That's a good question.
Will the platform move beyond simple field filtering to enforce deeper, context-aware data governance? For example, automatically redacting sensitive paragraphs or blocking retrieval entirely based on the content of the text and the role of the requesting user, enforcing data security policies during the vector retrieval process itself.
That's the next frontier.
That is the cutting edge of AI governance that you, the newly certified specialist, will need to consider as you architect future solutions. A compelling thought to end on, highlighting that today's exam requirements really do lay the foundation for tomorrow's complex security challenges.
Well said.
Thank you for joining us on this highly focused deep dive into the specifics of Agentforce. Go crush that exam.
Okay, let's unpack this. Today's mission is surgical. We are not conducting a general overview. We are performing a highly focused deep dive. We're specifically tailoring this to close those critical knowledge gaps we've seen in preparation for the Salesforce Agentforce certification. Our success metric today is retention and precision. zeroing in on the nuanced world of prompt engineering, dynamic grounding, and data management within the platform.
That focus is exactly right, because for this level of certification, just knowing the answers isn't enough. You have to master the mechanisms. Our goal is to dissect 5 specific, highly technical areas that come directly from some of the more challenging practice questions. We'll provide the essential context on why these solutions are the only correct choice, really turning these complex details into memorable knowledge for your exam.
And we have a clear blueprint to follow. First, we're covering the purpose and structure of specific prompt template types. Then we're moving into advanced data integration, how to handle things like JSON using Apex. After that, we'll analyze the critical role of dynamic data grounding through Data Cloud. And finally, we'll address the practical, non-negotiable management of fundamental model limitations, specifically token counts.
Exactly. To really succeed in prompt engineering, you have to understand the relationship between the front-end template design and the back-end data architecture. Every choice in Agentforce is driven by a specific task. Whether you need to synthesize data into a single narrative, personalize communication based on customer behavior, or just ensure a complex array of related records is interpreted correctly by the large language model. We're going to proceed with maximum depth to secure this foundational technical mastery.
We'll begin with the fundamentals of template usage, because the platform provides these specialized tools, and selecting the wrong one is a very common certification trap. The operational goal is it generating a cohesive document, writing an email, or just populating a single piece of data that absolutely dictates the specific template you select in Prompt Builder? Let's start with a scenario that often trips people up: generating detailed product descriptions. So the scenario involves universal containers, or UC. They need a prompt template specifically designed to create detailed, consistent product descriptions for their marketing materials. The key requirements are consistency, a detailed narrative output, and the ability to draw from the latest structured product data, which is spread across many different fields. Which template is the right tool for this kind of synthesis task?
The required template type in this specific scenario is unequivocally the record summary template.
And that is the crucial distinction we need to hammer home. Because, intuitively, the name summary makes people think of a short synopsis. And if the final output is going into a text field called marketing description, a lot of listeners might wrongly assume field generation is the tool. Can you walk us through the precise function of the record summary template and why it's the correct choice here?
Sure. The name is, I'll admit, a little misleading if you interpret summary as just abbreviation. The function of the record summary template isn't just to summarize. Its core technical purpose is to act as a synthesis engine for narrative generation. Its structure is explicitly designed to ingest data pulled from multiple structured fields on a source record.
Multiple fields. Okay.
Right. And these can be different data types, different lengths. They can even come from a few related lookups.
So just to make it concrete, we might have, say, 6 separate fields: product dimensions, material composition, environmental certifications, origin, price, and warranty details.
Exactly. The record summary template is tasked with synthesizing all 6 of those disparate structured data points, and then it weaves them into a single cohesive long-form narrative, a flowing paragraph, or even several paragraphs of marketing copy. This is fundamentally different from just outputting the content of one field.
So what's the critical why it matters factor here, especially when you think about consistency and data governance for a company like UC? Why is it so vital that this content is generated this way?
It's vital because of data governance and accuracy. It's that simple.
Yeah.
If a product manager updates the material composition field, let's say moving from standard plastic to 50% recycled plastic, that data update immediately changes the structured source field.
Right. If the source of truth is updated.
The source of truth is updated. So when the record summary prompt runs again, it pulls that latest, accurate, structured data. This integration ensures the resulting marketing description aligns precisely with this single source of truth, the structured data on the record. If UC were manually writing these or using a less sophisticated tool, you'd have a high risk that the marketing copy would misquote specifications. That could lead to compliance or, customer expectation issues. The record summary template forces consistency by tying the narrative output directly to the live structured fields.
That's a really powerful point. The template ensures that the descriptive text is always an accurate reflection of the current underlying data architecture. Now, let's tackle the primary confusion point: differentiating this from the field generation template. That one seems intuitively correct if your goal is to generate text for a single field.
The distinction lies entirely in the scope of the input and the output. The field generation template is highly constrained. It's intended for a much narrower specific task, generating a short piece of content to populate a single field within a record. You should think of it as data augmentation for just one slot. Some examples might be generating a quick tagline, or suggesting a sentiment rating based on recent notes, or maybe suggesting a next stage in a workflow.
So if UC wanted an AI-generated product code suffix or maybe a suggested short-form SEO title, field generation would be the right tool.
Absolutely. It's designed to be concise, focused, and it typically operates on a very limited subset of input fields. It's structurally insufficient, and it's not designed to handle the complex input synthesis required to produce a long, cohesive narrative, which is what a product description inherently is. On the exam, if you see the requirement emphasizing synthesis of information from multiple fields into a flowing narrative, you should immediately select record summary and just block out field generation. That synthesis requirement is the classic trap indicator.
And just briefly, to close the loop on the options, we should also exclude the sales email template.
Right. The sales email template is specialized for interaction and communication protocols. While it generates text, its primary structure is built around communication templates, recipient info, and outreach context. It is not the designated tool for generating and maintaining static descriptive record content for, say, internal or external product literature. So to summarize, if you need a descriptive multi-field synthesis narrative for a record, the technical tool you must select is Record Summary.
Okay, so moving from general product descriptions to direct customer communication brings us to personalization, which of course layers complexity onto content generation. The next scenario involves UC needing to generate a marketing email that recommends products. But critically, this recommendation has to be based on a customer's expressed interests. This is hyper-personalization, not just some general outreach.
And this specific requirement, it necessitates solving a dual problem. You have to provide the communication structure, which is the email, while also ensuring dynamic data inclusion that drives the content decisions, the personalization part. The correct technical solution here has to be a custom sales email template, which is grounded with interest and product information.
Okay, we understand why the custom sales email template provides the communication framework, but the critical, sophisticated mechanism here is the grounding. Before we dive into the data, let's just clarify the fundamental difference between sending data with a standard merge field and using a grounding mechanism.
That is the core distinction the exam is testing. A standard merge field is resolved before the prompt ever hits the large language model. It takes the field value, say the customer's name or their city, and it just substitutes that raw string into the text of the prompt instruction. It's a simple, static insertion.
It's basically a text replacement operation.
Precisely. Grounding, however, is far more advanced. Grounding takes specific, relevant, real-time Salesforce data, and this is often high-volume data like related records, interests, or activity logs, and it packages it up in a specialized wrapper. It then injects it directly into the LLM's context window as structured external context data. And that context window is where the LLM does all its reasoning and generation tasks.
So if we didn't use grounding in this scenario, what would actually happen?
The LLM would generate a perfectly structured email, but it would be completely generic. It might recommend product X because that product is generally popular or, it's prominent in the model's training data. It has no mechanism to know that this specific recipient expressed an interest in sustainable outdoor gear. Without grounding, the LLM is just operating on its general knowledge, and that results in generic, non-actionable content.
Right. So for the scenario to succeed, the LLM needs to receive two critical data sets during generation. The customer's specific expressed interests data that's maybe stored in a custom object linked to the contact, and the details of the available product information that actually aligns with those interests.
And the grounding mechanism forces the LLM to process these two specific data sets alongside the prompt instructions. This is the sophisticated part. The AI is being asked not just to write an email, but to analyze the grounded customer interests, match them against the grounded product catalog, and then dynamically select and describe a product that genuinely matches that customer's profile.
How?
This process moves personalization from simple insertion, like a name, to data-driven content decision-making and creation.
I want to challenge this for a second. If UC has a really complex Apex flow that retrieves the customer's top interest, finds the matching product ID, and then uses a standard merge field to insert the predetermined product name, wouldn't that achieve the same result without needing advanced grounding? Why do we have to rely on this AI grounding combination?
That's an excellent point, and it really highlights the insufficiency of traditional methods in this context. A complex Apex flow could certainly determine which product to recommend. However, It cannot perform the personalized linguistic generation that's required.
Meaning the flow can deliver the name EcoTrek backpack, but not why the EcoTrek backpack is being recommended.
Exactly. The flow can only deliver static results. The AI-driven generation, which is enabled by the grounding mechanism, allows the system to analyze the customer's multiple interests against the product data and then write the specific, persuasive text that explains the match. For instance, the AI can generate a paragraph saying, "Because your profile indicates a strong interest in sustainable manufacturing and lightweight materials, we highly recommend the new EcoTrek backpack, which features recycled polymers and a 5-pound weight reduction." A standard flow just cannot perform that personalized analysis and write that tailored, flowing, and persuasive text on the fly.
So the critical takeaway for the exam is that the moment the requirement involves sophisticated personalization, which means dynamic matching against complex record data to generate original, contextually relevant prose, you have to look for the solution that combines an AI-driven template type, like the sales email, with the necessary Salesforce data grounding mechanism. It's the combination that unlocks the capability.
That is the essential insight. Grounding ensures the LLM reasons on the specific narrow data you provide, rather than just guessing based on its general training. This distinction between mere data insertion and data-driven content creation is foundational to passing this section.
Okay, building seamlessly on the necessity of grounding, we have to pivot now into the mechanics of handling technical complexity. We've established that the LLM needs clean data. The next challenge is integrating complex data, often sourced from outside the immediate record, and making sure it is structured correctly for reliable interpretation by the large language model. This moves us beyond simple merge fields into programmatic integration.
This next section addresses a key technical requirement for data-intensive applications. UC wants to incorporate complex CRM data into a prompt, maybe an array of recent transactions, or detailed pricing configuration tables. But they specifically require that this data be delivered as well-formatted JSON to the large language model. This requirement of structured delivery is paramount.
So let's revisit the critical limitation. Why can't we just use a standard merge field or related list grounding to pull in that complex record data, especially if it's an array of related records?
This is where LLM robustness comes into play. Standard merge fields, or just pulling a list of related records, often returns raw, unstructured verbose text. Imagine retrieving a list of, say, 20 related opportunity products. The standard output might be a long, dense block of text, maybe separated by commas, listing product A, quantity 5, price $100, product B, quantity 2, price $200, and so on.
That sounds like data soup for an LLM that's trying to accurately pull specific values.
It is data soup. The LLM has to guess where one product ends and the next one begins, or which number represents the price versus the quantity. With complex relational data, that raw format introduces ambiguity and dramatically increases the error rate in the generative output. For reliable analysis or accurate generation, the LLM needs structured input that follows a predictable schema. And JSON provides that structure, using clear keys, arrays, and predictable key-value pairs.
So JSON provides a rigid contract, ensuring the data is machine-readable and highly predictable. Therefore, the core solution required to guarantee this structured delivery is using Apex code to return a JSON-formatted merge field.
Correct. Apex is really the only platform mechanism available to programmatically enforce that data structure before you pass it to the prompt builder context window.
Let's dedicate some time to breaking down the precise workflow. How does Apex code successfully transform that raw relational CRM data into pristine JSON? And then how does that transformation make it available to the specialist in prompt builder?
The Apex code, in this case, acts as a data architect. The function is highly technical. First, the Apex code has to execute a programmatic query, a SOQL query, to retrieve the complex CRM data. And this could mean traversing multiple related objects. This allows the developer to customize exactly what data is pulled and in what sequence.
So it's gathering all the necessary ingredients.
Yes. Second, and this is the most crucial part, the Apex code uses built-in serialization features. In Apex, this involves using methods like JSON.serialize, or constructing a map or list hierarchy that can then be serialized into that strict JSON format. This process wraps the raw data, defining clear keys like product name, EcoTrek backpack, quantity 5. It ensures predictable formatting, correctly handles arrays, and manages nested objects if needed.
So the developer uses Apex to programmatically build the exact JSON payload the LLM is expecting, which eliminates all the ambiguity.
That is its function. And once this code successfully executes and generates the structured JSON output, this custom logic has to be exposed to the Agentforce platform. This is achieved by wrapping the Apex logic into something like an invocable method or a similar structure that can then be accessed and surfaced as a custom field or merge field within Salesforce's data model.
And when the specialist is in Prompt Builder, they just select this custom field, which to the user just looks like any other field. But when the prompt runs, the content of that field is not raw text, but that entire beautifully structured JSON block generated by the Apex.
Precisely. This step is fundamental. It ensures that when the LLM reads the input, it's receiving data that is deterministic and reliable. This dramatically improves the accuracy of complex generative tasks, whether that task is analyzing transaction history for patterns or comparing product configurations. The implication for the exam is this. If the requirement specifies structured output delivery to the LLM, like JSON, Apex is the mandatory platform tool to programmatically enforce that structure.
That technical deep dive leads us directly to high-volume external data integration, and specifically Data Cloud. Data Cloud typically houses these vast amounts of behavioral, operational, or clickstream data, far exceeding what a core CRM object can store natively. The scenario is, UC tracks detailed web activities in Data Cloud for a unified contact, and they need to use these dynamic activities inside a prompt template, where the contact record is the basis to extract real-time customer behavioral insights.
And this really tests the architectural link between Data Cloud and Agentforce grounding. The central challenge is bridging that high-volume external activity data from Data Cloud to the context window of a specific contact record inside Prompt Builder. The data is just too massive and too external for standard merge fields.
Okay, so what is the specific multi-step pathway required for UC to achieve this level of dynamic external data integration?
The correct solution relies on the specific integration capabilities of both platforms. It requires UC to first decame, add the activity records as an enrichment-related list to the contact, then pass the contact into a prompt template workspace using related list grounding.
Let's dissect the Data Cloud side of that first. I want to model the listener's potential confusion here. What does Data Cloud enrichment achieve that a standard lookup relationship cannot, especially when you're dealing with high-volume behavioral data? Why is enrichment the specific term here?
That is an excellent point. Enrichment isn't just a fancy name for a lookup. Standard lookups manage direct, defined relationships within the core CRM database. Data Cloud, however, is designed to ingest and unify these massive disparate datasets, the billions of web activities, purchase orders, email opens, that would just crush the core transactional database.
The scale is the main difference.
Exactly. Data Cloud takes those activity records and, through its resolution rules, it enriches the core contact record. The outcome of this enrichment is that these high-volume activities are surfaced back to the core CRM instance. And they don't come back as fields, which would overwhelm the contact object, but as specialized high-volume related lists attached to the contact record itself. This structural relationship establishes the pathway that Agentforce needs.
So the activity data stays in Data Cloud or a governed layer, but its relationship is clearly defined on the contact record. Now, what's the crucial mechanism in Prompt Builder that makes this dynamic link operational?
That mechanism is related list grounding. This is the feature within Prompt Builder that understands Data Cloud enrichment architecture. When the prompt template is run for a specific contact, the related list grounding dynamically resolves and pulls the associated related list data, in this case, the enriched web activities, into the LLM's context window.
This makes sure that the grounding is always narrow and relevant. So if I run the prompt for Contact A, whose Data Cloud profile shows they clicked on 10 specific product pages today, I only get those 10 activities injected for context.
Precisely. Related list grounding is the operational key that facilitates this dynamic context injection. It allows the LLM to perform complex behavioral analysis like inferring the customer's current buying intent, extracting specific product engagement patterns, or summarizing recent activity trends based on that dynamic, high-volume external Data Cloud information. This effectively extends the context of the contact far beyond the fields stored natively on that object.
This integration represents a major architectural leap in Agentforce. You're no longer limited to just static CRM fields. You can incorporate the entire scope of the unified, behavior-driven customer profile. The exam insight here must be centered on that specific sequence: Data Cloud for enrichment and Agentforce's related list grounding for the injection.
That dual understanding is critical. The related list grounding capability is the designated platform mechanism for incorporating these dynamic, external, and typically high-volume behavioral datasets into an AI generation context. If the question involves leveraging detailed activity data for personalized insights, you need to look for the related list grounding solution that's tied back to a data cloud-enriched object.
Okay, so we've spent a significant amount of time discussing mechanisms that allow us to bring more and more complex data into the prompt context, from Apex formatted product configuration to data cloud activity logs. But as we increase the volume of grounded data, we inevitably run into the hard technical limitation that governs every single LLM interaction: token limits.
This constraint is perhaps the most fundamental operational necessity. When you run a prompt template in Agentforce, every piece of input data, the prompt instructions, the field merge data, the Apex JSON output, and that high-volume related list grounding all contribute significantly to the overall token count.
Let's clearly articulate the potential disaster if that token limit is exceeded. What does truncation mean in practical terms for the generative output?
If the total input data exceeds the model's token capacity, the data is just summarily truncated. This means the LLM receives only the beginning portion of the grounding data, and anything that exceeds the limit is simply cut off. For instance, if you are grounding a list of 50 recent customer activities and the limit is exceeded halfway through, the LLM is only going to receive the first 25.
Which means the LLM might be reasoning on old, irrelevant data and potentially missing the most critical, most recent context that was at the end of the input.
Precisely. The outcome is often an unreliable, sometimes completely inaccurate output because the LLM is reasoning without the full critical context. Proactive management of this limit is absolutely non-negotiable for deploying reliable prompts.
So what is the single core requirement for the Agentforce specialist to ensure the size of this grounding data is monitored and controlled to prevent that critical data truncation?
The specialist must proactively review model limitations in Prompt Builder.
Why is going straight to the platform's configuration the necessary first step? I mean, why can't we just rely on trial and error or external documentation?
Because Prompt Builder is the single source of truth for your prompt's operational environment. It provides clear, direct visibility into the specific technical constraints of the underlying large language model you have selected. This includes the model-specific token limits, the absolute maximum input size that model can handle for the prompt, the grounding data, and the expected output, all combined. And these limits are subject to change based on model updates or platform configuration.
So this isn't just a reactive fix, it's an absolute requirement for proactive capacity planning.
Absolutely. Reviewing these limits before deploying or even testing the prompt is the necessary proactive step. By knowing the exact capacity, say 4,096 tokens, the specialist can then intelligently adjust the quantity of data being grounded. For example, if the data cloud enrichment typically results in 100 activities, the specialist knows they must implement constraints, perhaps limiting the related list grounding to only the top 15 most recent activities, or querying only the activity type most relevant to the prompt's purpose. Without knowing the capacity limit that's provided right there in Prompt Builder, the specialist is simply operating blind and risking truncation under production loads.
That brings up a point of clarification regarding some common exam distractors. Let's clarify why measures like offset queries don't address the specific problem of monitoring and managing the hard technical token limit.
Right. Offset queries are a data retrieval technique, not a capacity monitoring tool. They're used in data queries, like SQL, to manage pagination, or to skip a certain number of records in a result set. And while an offset query can help reduce the volume of data retrieved from the database, it doesn't inform the specialist about the maximum token capacity available for the chosen large language model itself. The offset addresses the size of the result set. It doesn't address the size limit of the LLM context window. You need to know the capacity before you decide on the offset.
And what about the trust layer? Where does that fit in the architecture, and why is it irrelevant to token management?
The trust layer is deployed between the Salesforce data and the large language model. Its function is crucial, but it focuses entirely on data security, governance, and compliance. It handles tasks like masking sensitive information, PII, before the data leaves the trusted Salesforce environment, ensuring data doesn't violate any privacy policies. It's about data safety. It has absolutely no function in measuring, displaying, or managing the technical input capacity constraint of the model itself.
So the relationship is clear and highly specific for the exam. If the problem is about preventing data truncation due to size, the answer must be about seeing the size limit, which is uniquely displayed and managed through configuration settings within Prompt Builder.
That relationship problem. Token truncation risk. Solution. Review model limits in Prompt Builder is a direct technical link that must be established firmly in your mind for certification success. It ensures you manage the technical boundaries of the generative AI platform. If we connect this detailed technical review to the bigger picture, we have successfully dissected 5 specific, high-value technical relationships that define effective Agentforce prompt engineering. We started by establishing the need for narrative consistency, identifying the record summary template as the necessary tool for synthesizing information from multiple structured fields.
Right. Then we advanced to personalized communication, understanding the enhanced capability you get from a grounded sales email template. That injects specific, real-time Salesforce customer interest data into the LLM's context window, moving beyond simple merge fields to actual data-driven content creation.
Then moving into complex integration, we mastered the architectural requirement of using Apex code for JSON serialization. This is the programmatic enforcement mechanism that ensures complex CRM data, which would be data soup otherwise, is delivered in a reliable, machine-readable format for accurate LLM parsing.
And following that, we explored the dynamic power enabled by data cloud enrichment and related list grounding. That whole process allows dynamic, high-volume behavioral activity data to seamlessly extend the context of a core CRM object like the contact record, enabling advanced, real-time behavioral insights within the prompt.
And finally, we close with the operational necessity of managing hard constraints. That non-negotiable step of checking token limits directly in Prompt Builder to proactively manage grounding volume, prevent data truncation, and maintain the fundamental reliability of the generative output.
You should view this information not just as facts, but as a map of the platform's technical dependencies. Understanding the mechanism, the why behind using Apex for serialization, or the precise architectural function of related list grounding, that is the difference between knowing the general concept and successfully selecting the precise required tool within the platform context, which is really the definition of preparation for this certification.
And this raises an important question that extends beyond the current exam material. As the reliance on external and high-volume data sources increases, incorporating not only data cloud but potentially real-time streams and multiple external APIs, how will platforms like Agentforce continue to evolve methods beyond just simply expanding the context window to seamlessly manage, govern, and effectively ground massive volumes of highly variable data without compromising accuracy or performance? That necessary evolution of grounding architecture is a topic worth exploring further as you continue your journey through advanced prompt engineering.